All right, today we're cracking open the skull of artificial intelligence. We're going to look at the elegant and, surprisingly simple system that really acts as its brain. This is going to be good. Let's get into it. So what do a self-driving car and a philosopher have in common? I know, it sounds like the setup to a really nerdy joke, right? But the answer is actually fascinating. Both of them, in their own very different ways, have to rely on the ancient art of logic to figure out the world. And that's exactly what we're breaking down today.
So whenever you hear someone say that an AI thinks or that it makes a decision, what is actually going on under the hood? Well, for a huge class of AI systems, it is absolutely not magic. It's all based on a really structured, really powerful system for reasoning called propositional logic.
And here's the crazy part. At its absolute most fundamental level, this entire system just boils down to one simple binary question. Is something true or is it false? That's it. There's no maybe, no kinda, no sort of, just a clean, crisp yes or no. And believe it or not, that's the foundation for everything we're about to build. Okay, so if you wanted to build a thinking machine from the ground up, where would you even start? Well, you'd start with the absolute basics, the simplest possible pieces. So let's take a look at the building blocks of this logical language. The very first piece of the puzzle is something called a proposition. And really, that's just a fancy word for a simple statement that can be either true or false, with no ambiguity. Like, it is raining. You just look outside your window and you know the answer. Or, the sky is blue. The car's battery is charged. See? All of these are propositions because they have a clear-cut, verifiable, true or false answer. But life, of course, is way more complicated than just one simple fact at a time. So we need a way to connect these little propositions together. And for that, we use a set of tools called logical operators. You can almost think of them as the grammar or maybe the conjunctions, the ands, ors, and buts of our logical language. So first up, we've got and. Now, the and operator is, well, it's pretty strict. It insists that for a whole statement to be true, every single part of that statement has to be true. No exceptions. So think about it. If you want to go to the beach, it's not enough for it to just be sunny. It also has to not be a workday. If even one of those things isn't true, if it's cloudy or if it's Monday morning, the whole plan is a bust. Now, next up is the much more chill, much more flexible or operator. This one says the whole statement is true as long as at least one of the little parts is true. It's like for a snack, you'd be happy with chips or a cookie. Heck, you'd be happy with both. As long as you get at least one of them, the condition of I got a snack is totally 100% true. And the simplest of all is not. It does, well, exactly what you think it does. It just flips the truth value of a statement on its head. So if the proposition "it is sunny" is true, then obviously "it is not sunny" has to be false. Simple as that. Okay, so now we have our basic Lego bricks, right? We've got propositions, and we have the operators to stick them together. So how do we actually combine them to build something that starts to look a little bit like, well, reasoning? This thing right here, this is called a truth table. And you can basically think of it as the AI's cheat sheet for logic. It just systematically maps out every single possible combination of inputs to guarantee the correct output. So if you look at the table for P and Q, you can see it right there. The only way to get a true at the end is if both P and Q are true to begin with. It's a system that leaves zero room for guesswork. It guarantees the right answer every single time. And this is how it all comes together. This is where the magic happens. We can program a simple rule into a system, something like, if it's raining, then the streets are wet. Then later, the AI gets a new piece of information, an observation. It is raining. Boom. It immediately applies that rule and deduces with absolute certainty, therefore the streets must be wet. That right there, that is the core of automated reasoning. So as you can see, this isn't just some abstract exercise for philosophy class. This logical framework is the actual engine driving some really specific and really powerful types of artificial intelligence that are out there in the world right now. Now, it's really important to get this distinction. The AI you hear about most these days, right? Machine learning, that stuff learns by finding patterns in just massive amounts of data. But there's another kind, symbolic AI. Some people call it good old-fashioned AI. And this kind is totally different. It's built on these explicit, handcrafted logical rules we've been talking about. And here's the key takeaway. Its decision-making process is completely transparent. You can literally trace every single step of its logic to see how it got to an answer. And this stuff is not just theoretical, it's used in some super critical applications. Think about expert systems in a hospital following a strict set of diagnostic rules to help a doctor, or automated scheduling software for a shipping company that has to follow rules like if the truck is full and it's past noon, then that truck must leave. It's even baked into the design of the computer circuits you're using to watch this right now. But, as powerful and as clean as this system is, it is not perfect. In fact, its greatest strength, that absolute black and white certainty, turns out to also be its greatest weakness. I love this quote from Thomas Huxley because it just captures the dilemma so perfectly. You can build this beautiful, flawless, logical system that works perfectly in its own little world. But the real world is messy, and all it takes is one ugly fact, one piece of data that doesn't neatly fit into a true or false box to make the whole beautiful structure come crashing down. And that really gets to the heart of the limitation here. Propositional logic just has no way to handle uncertainty. How does it deal with concepts like maybe, or probably, or most of the time? It can't. Our world is filled with shades of gray, but this entire logical system can only see in pure black and pure white. Which, of course, leaves us with a really big, fascinating question to think about. If an AI's most basic foundational logic is strictly binary, just true or false, can it ever really truly understand the rich, complex, messy nuance of our world? And honestly, that's a challenge that the smartest people in AI are still wrestling with today.